All righty, y'all. Good morning. So again, what we're doing now is statistics, and statistics is about organizing data. Okay, it's also about trying to find numbers that are used to represent the underlying data. And we've looked at the mean, the median, the mode, and the range of data. Good morning. Have a seat. Okay, so here we have some data, and this data is the number of accidents per 1,000 people based upon their occupation. So out of 1,000 farmers, 43 of them are going to have an accident on average every year. And you can see there's a whole lot of occupations, right? So an engineer, out of 1,000 engineers, 93 of them are going to have an accident on average per year. And fortunately, the data is organized in order. So from the lowest all the way to the highest, which is 152. So out of every 1,000 students, 152 of them are going to have an accident on average per year. Okay, so again, I told you what to do. Maybe that was helpful, but we want to start at 40. Notice 40 is a little bit less than the largest number. Smallest number, and go by tens. Now, there's no hard and fast rule how to create your categories, right? So generally, whatever is easiest is the way we do that. And it's definitely easier to use multiples of 10. Okay? All right. So again, we've been doing this a couple different times, so maybe we're okay with this, but I'm making sure. So we're going to start at 40 and then add tens. And then once we get to 150, when we add 10 again, that's 160. We'll include that as the last number in the last category because that's a little bit bigger than the largest number, 152. Okay, so we started 40, which is a little bit less than the smallest number, which was 43. Add tens, and then once you get to 150, when we add 10 again, 160, we put that as the last number in the bottom category since that's a little bit bigger than 152. Okay. All right, and then now we want to find the other numbers that are the last numbers in that interval. So from 40 to 49, next category you start at 50. From 50 to 59, next category you start at 60. From 60 to 69, next category you start at 70. So notice we're always going one back from the next number in the interval. So all these other numbers are going to have nines at the end. Okay, now for if we're going to find the median, we need to count how many numbers there are. And I'll tell you there's 40 numbers. So I'll spare you having to count them all. But you might miscount. Okay? And come on. All right, so go ahead and count where these numbers occur. Now, they're all multiples of 10, and since the data is organized, you can kind of section off all of the multiples. So the 40s, 60s, 70s, the 80s, and here, the 90s. So it's a little easier to determine how many numbers are in each category, since the numbers are in order. If they weren't in order, that'd be a little more demanding. Okay, so go ahead and complete your frequency table. You can use tally marks, or if you want to just put the count. So again, since we're dealing with numbers that are from 43 to 152, and we're organizing the data based upon tens, well, there's only one number in the 40s. So there's only one number between 40 and 49. There's no 50s. There's one number that's a 60, 67. So there's no 50s. There's one number that's a 60. How many 70s are there? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 70s. Okay, how many 80s? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, that's what these mean. We call those frequencies. How many numbers occur within each interval? So it's a matter of counting how many there are. All right, so if you count the 90s, you'll get 13. And if you count the numbers between 100 and 109, there's 4 of them. And then no numbers in any of the other intervals until you get to the last interval, 152. There's only one number in that interval. Okay, so notice this data. Most of the data is between 60 and 110. There's 2 elements of data that are much further away than everyone else. So we call those outliers. There are data values that are so much different from the vast majority of the data that they're not really representative. And that usually means data values that come from some element or some aspect that is unique. Okay? Well, what's the smallest number? 43, farmers. Now, why do you think farmers would have the least number of car accidents? What's unique about farmers? And that includes you in the chat.
They don't drive much.
They don't drive much. Probably true. Anybody else think of a unique characteristic of farmers? Why is it so much less than everybody else? They live in rural areas with less traffic. That's also true. Okay. And what's the largest number in this group? Students. And notice much, much bigger than everyone else. Okay, now what do you think is unique about students? Why do you think students would have the most accidents than everybody else? What do you think is unique about the student population? Peyton? They're just learning to drive.
They live in cities, like closer to the quality.
Well, there are students that live in rural areas. But you know, it's a good thought. Okay, yeah, students are just learning to drive. Now, what do you think sometimes happens by young people? What's
They drink and drive.
They drink and drive. Okay, they make poor choices in the moment. And I'm not saying that as a negative. I was a young person too, and I sometimes made poor choices in the moment myself. That's why this is happening. Okay, now not every student is irresponsible, not every student, but a good number of them are, and this shows up in the data. Okay, so we call those outliers. Now there's a mathematical way to determine them. We're not going to worry about that. Okay. All right, now let's finish. So we want to locate the median. If you counted how many numbers there are, you would get 40. Notice if we add the frequencies, we should be getting 40. All right, so let's do the n plus 1 divided by 2. All right, so that means in between the 20th, 21st number. Now, if we had to do that with the frequency table, like we've done in the past, it'd be a little more demanding. But we already have the numbers in order. Okay? So this would be the first number, second number, the third number. That's the 20th number. And then this would be the 21st number. And notice they're both 89. So if you're in the middle of 20 and 21, the 20 and 21st number, and they're the same number, that means the median is also 89. So the median is 89. And that is located in this group. Notice it's not the same as the mode. It's near the mode, but it's not the same. Okay? And more than likely, the average is being pulled this way, the mean. It's going to be shifted in the direction that the mode got pulled. And that's because of the influence of the much larger number that is so much larger than every other number.